Hey guys, today's video is about making sure you're on the level by checking your level. This is the first step you should perform when getting a new level and periodically throughout its use. There's actually a lot that goes into making a level, and it needs to be accurate to work properly, from the beam construction to vial properties and geometry. Not to mention mounting the vial so it stays true and doesn't move. How a level is made and what makes a quality level will be another video. Today we're going to look at how to check your level. Levels have two measuring positions, level and plumb. But what does that really mean? To understand it, we'll have to take a closer look at the Earth. You might be used to thinking the Earth is perfectly round, when in fact, it's actually considered an oblate spheroid, thanks to Isaac Newton. At the equator, the Earth is approximately 27 miles wider in diameter than the North and South poles. This is caused by the rotational forces and gravity acting on the Earth. In reality, gravity can be different along the surface of the Earth due to changing density and position. But for our purposes, let's assume a gravitational line from the center of the Earth to the surface. Level would be perpendicular to that line, meaning 90 degrees. From your point of view, it would seem horizontal. And you can see as you move around the Earth, level changes. Then there's plumb. Plumb is a line that is perpendicular to level. You can see it's also a continuation of the line from the center. From your point of view, it will seem vertical. And just like level, it changes as you move around the Earth. Notice when the level is level, the vial is parallel to the body and in the horizontal position. When the level is plumb, the vial is still in the horizontal position, it's just rotated 90 degrees, so it's perpendicular to the body. So how do you make sure your level is level and plumb? To start, you need to find which edge of your level is the registration edge. There are levels made with one registration edge and some with two registration edges. Most levels have one registration edge because you don't really need two edges, and you can maintain a higher accuracy on one edge. This doesn't mean the other edge isn't accurate, it just means the vial was not calibrated to that edge and might not have the exact same accuracy as the registration edge. This is important to know when using your level. On this level, the registration edge is unpainted, showing the aluminum color. There are two ways to use this level: standard position, when the level is on top of the material, and inverted, when the level is under the material and inverted. There are several ways to check your level, with varying degrees of accuracy. You can place your level against the wall and level, then draw a line, rotate the level horizontally end for end, and check the bubble. This can also be done in the plumb position. The obvious inaccuracies of this method are the many variables you can add to the test, such as keeping the level from moving, which gets more difficult the larger the level, accurately drawing a line, and visually being able to judge the bubble's location. Another method is to place the level on a flat surface, read the bubble, rotate the level horizontally end for end, and check that the bubble is in the same position. This method does eliminate the variable of having to hold the level and draw a line, but you're still having to judge where the bubble sits between the lines. This can be difficult and less accurate. The next method is going to eliminate all those variables, allowing you to accurately test your level and calculate the tolerance. Start by grabbing two pieces of wood. You can simply use two 2x4 scraps, as you see here, then install a flat top screw, like a drywall screw, in one of the pieces, and place the blocks at the ends of the level. The edge of the level beam, not the end caps, should be touching the wood and screw. Make a mark on the wood so you can place the level back in the same spot. Now adjust the screw so the edge of the bubble touches the line. Then rotate the level horizontally end for end and recheck the bubble. If it's still touching the line, then your level is perfectly level. If there's a gap or your bubble is now past the line, you'll need to check that the level is within tolerances. The test we just did is for the level in the standard position. To check the level in the inverted position, just flip the level over so the registration side is pointing up and repeat the test. To check if your level is plumb, we will repeat these same steps on a vertical surface. Using two screws, one at the bottom and one at the top, just like level, adjust the screw so the bubble touches the line. then flip the level end for end and recheck. If you find your level to be out, then you need to check that it's within tolerance. Start by looking at the specifications on your level. In this case, I have the degree value and a measurement per unit length in both the standard and inverted positions. I'm going to use the angle measurement given to determine if my level is within tolerance. To do this, I need to use a little trigonometry. In this video, I'm just going to show you how to calculate it. I will be making a video on using trigonometry for building and woodworking that will change the way you work and drastically increase your skill. So stay tuned for that. So how do we use this to check our level? Because we know the angle is 0.017 degrees and the length of the level body is 94.5 inches. Note, this example is not to scale, so it's easier to see. We need to find the height of the triangle. This represents the total tolerance. The ratio in length between the height and the base is called the tangent of the angle. Enter the angle in your calculator, then press the tan button. Take this number and multiply it by the length of your level, in this case, 94.5 inches. This equals 0.028, which means the level can be 28 thousandths of an inch out along its total length. That's 3.25 thousandths less than a 32nd. Now, what do we do with this? After you've checked the level and found it to be out, take your dial calipers and measure the height of the screw. Next, put the level back and adjust the screw until the bubble touches the line. Then recheck the height of the screw. If it has changed more than 28 thousandths, then your level is out of calibration and you need to get it fixed or replaced. Remember, it isn't level because it looks level. It's level because it is level. Thanks for watching, stay level, and I'll see you next time.